Two small bodies of mass 10 kg and 20 kg are kept at a distance 1 meter apart and released. Assuming that only mutual gravitational forces are acting, find the speed of the particle when the separation decreases to 0.5 meter. Fine. Now let's say I do have two particles that are kept at a 1 meter distance. Initially, this is my particle A, this is my particle B. Now the gravitational force will act between them, and we know that the gravitational force is an internal force. So if and only if gravitational forces are acting between two particles, then the linear momentum will remain conserved, alright. So I can write initial momentum is equal to final momentum, although initial momentum is 0 because mass m1, let's say the mass m1 is this, mass m2 is this, so m1 into 0 plus m2 into 0, because initial velocity of both of them are 0, is equal to final momentum. So it will be m into, let's say, v1 and m2 into v2. Fine. So I'll solve this equation. Mass m1 is 10 kg, let's say velocity is v1, that will be minus of 20 into v2. So v1 is equal to minus 2 times of v2. The minus sign shows that the direction of the velocity of v2 is opposite to that of v1. Then of course if the velocity of v1 is in this direction, then the velocity of v2 is in this direction. Fine. So as of now I can neglect the negative value because that is just showing the direction. So I do have this relation, let it be 1. Okay, now initially there will be some gravitational potential energy. Fine. The gravitational potential energy, let be u1, will be given by minus g m into m by r. Substitute the value of g is 6.67 into 10 to the power minus 11 into 10 into 20, and the distance between them initially is 1 meter square. So initial potential energy comes out as 13.34 into 10 to the power minus 9 joules with a negative sign. Fine. And I'll calculate the potential energy when the distance between them is 0.5. So it will be minus again gm1 into m2 by r, and it will be minus of 6.67 into 10 to the power minus 11 into 10 into 20 divided by 0.5 whole square. So it is nothing but minus 13.34 into 10 to the power minus 9 divided by 4. It will be into 4. Fine. This is joules, and now what I have to do is I have to conserve the energy, that is the initial energy, that was only gravitational potential energy, that will be converted into the gravitational potential energy when the distance reduces to 0.5 plus the kinetic energy of mass 1 plus kinetic energy of mass 2. So just substitute the value. I do have minus of 13.34 into 10 to the power minus 9 is equal to minus of 13.34 into 10 to the power minus 9 into 4 is equal to half of 10 into v square plus half of 20 into 2v square. Fine, let it be v. So I'll put the velocity of 10 kg as v. I'll put the velocity of 20 kg as 2v. Fine. So on solving this equation I get the value of velocity as 2.1 into 10 to the power minus 5 meter per second. So this is the velocity of v1, and the velocity of v2, that is 20 kg, will be 2 times of it, so it will be 4.2 into 10 to the power minus 5 meter per second. That is our answers.